Hello guys, this is Prime Concept. We want to introduce a very important area of mathematics, which is conic section. So we're going to introduce conic section. Now, why do we call this aspect of mass conic section, right? And why is it important to us? We would later see the applications of this in ray optics in physics, right? So this can be applied in optics in physics. So, but let's not go into that for now. So we want to just study conic section. So why do we call it conic section? Is because when you have a cone and you split this cone through, or you cut this cone through different angles or through different directions, you're going to get different possible shapes when you cut a cone in different ways. And these different shapes that you can get by slicing through a cone, these different shapes are what we know as the sections of a cone. So we call them conic sections. So all the different shapes that you can obtain by slicing a cone, they all form what we know as what? Conic section. I will give a simple example. I will say this is a cone, even though a cone is a three-dimensional shape, but I can't draw it, so I will make it two-dimensional here. Say this is a cone. This is a cone, right? Yes. Now, if I decide to slice through this cone in such a way, I slice in such a way that my cutting is actually parallel to the base. If I do that, I would have a shape like this. So if I slice this cone such that I slice it and my line that slices this cone is parallel to the base, the shape I would get from that, when you slice and you turn it, you will notice that what you have gotten is a circle, is a circular shape, right? By slicing parallel to the base. Now, you may decide to slice this same cone no longer parallel but at a different angle, any angle that is no longer parallel. You can decide to slice like this. You can see this is no longer parallel to the base. Now, when you slice in any other angle that is not parallel to the base, the shape you would get is an ellipse. You would get an ellipse, while this one gives us a what? Circle, right? You can decide to still slice this cone this way again, slice it this way, such that this line is parallel to one side of this cone. If you slice in this way, you will get another shape, which is what? A what is the name? What is the name now? Okay, that's escaped my mind. But if you slice this way, you would get a different shape, right? Yes, now we have the circle, which you have seen. We have the ellipse. Then we have the hyperbola. Thank you. The parabola. I don't know how it skipped my head. So if you slice this way, the shape you would form is the shape of a parabola, right? Yes. So all these different shapes that can be gotten by slicing a cone, all these different shapes, we call them, they are all part of what we know as what? Conic section. So what are the shapes that makes up the conic section? The ellipse is one, a circle is part of the conic section, the parabola is part of it, and then the hyperbola. So all this together is what we know as what? Conic section. So in our study of conic section, we're going to be learning the ellipses, the ellipse, the parabola, the hyperbola. We've already learned circle in a different video. So we'll be considering or focusing more on ellipse, parabola, and what? Hyperbola. So you should understand any shape that can be gotten by slicing a cone is known as a conic section. So thank you, because the exam can ask you which one of these is not part of the conic section. They will put circle. Circle is part of it. Parabola is part of it. Hyperbola is part of it. Ellipse is part of it, right? So let's now at this point define a conic section. So what is a conic section? Definition. A conic section is a path traced out by a point, or we can say a conic section is a curve traced out by a point such that the distance from that point to a fixed point is in the ratio, or let me rephrase. This is a curve traced such that the ratio of the distance from a fixed point to the distance from a fixed line is a constant. So that is a conic section. So a conic section is a curve that is traced out such that the ratio of the distance from that particular point from a fixed point to the distance from a fixed line is a constant. So I'm going to illustrate this with a diagram so it will be clear to us. Now say we have our coordinate system like this. This is our y and then this is our x. So if I have a straight line like this that does not change, then I have, let's say, a point at this point, right? I have a fixed point somewhere around here. This point remains constant for a particular cone. It remains the same, it doesn't change. Now this point can change, right? Yes, it can be at this point, it can be at this one, but we have a point that does not change. So this point that is fixed, that does not change, I will call it f. While this line that does not change, I will call it D, line D. So a conic section is defined in a way that the distance from this fixed point, the ratio of this distance to any random point I choose. If I measure this distance, let's call this a random point P, and let's call this point A. So a conic section is defined in a way such that the ratio of this distance to this distance would always be a constant. What do I mean? What I mean is that PF, the distance PF over the distance PA, the ratio of this distance PF to distance PA would always be a constant. It would be a constant. That is how we define a conic section. So I believe that this definition is clear to you. Now take note that this point is fixed. It does not change, right? This line is also fixed for a particular conic section. It won't change, right? Yes, and then this point can change. So this point is a point that can vary. So anywhere, if I still locate at this point, the ratio of the distance will still be the same. So I still locate another point here. Ratio of this distance to this will still be what? The same. It will still be constant. So that is what this definition is actually saying. So quickly, what do we actually mean? This constant, what is it called? The constant in this definition has a name. The name of the constant that will always be obtained is called eccentricity. Eccentricity. And is denoted by the symbol small letter e. So the constant ratio that would always be obtained is known as eccentricity. So later we'll be defining the terms that are used in conic section, but for now, let me just mention. So that constant is eccentricity. Then that fixed point, which is f, the fixed point is known as focus. Of that conic section. Then that fixed line, the fixed line is known as directrix. So these are the things you would know. Later on, we'll mention the terms that are used in conic section and explain them so that you can really understand. When we say eccentricity, you would understand what it means. When we say focus, you would understand. Directrix, you would understand. So for now, just take note of this definition for a conic section. Right? Now, we want to state the general formula, just like we mentioned when we studied circle, that circles have a general formula. Can you still remember the general formula of a circle? Of course, I trust that you can remember. So the same way, conic section, which comprises of parabola, ellipses, hyperbola, right? They have and a circle, they have a general formula. So the general formula is given as ax squared plus bxy plus cx plus dy squared plus ey plus f. This is equal to 0. So it looks long, right? But don't be scared. We may not be using this directly to do anything. So, but this is the general formula for all the conic section. This equation can represent a circle, it can represent a parabola, it can represent an ellipse, it can represent a hyperbola. So that is why we call it the general equation for conic section. One thing that is important here is that this coefficient A, B, and D, these coefficients, at least one of them must not be 0. If these three coefficients A, C, and D, if the three of them are A, B, and D, if the three of them are 0, then this would no longer represent a conic section. So it means that it is important that at least one of A, B, and D should not be what? 0. So in that way, you have retained the conic section. So this is it. So let's take some example from this that would help us understand the concept of conic section well. At this point, we are not dealing with a parabola, hyperbola, or ellipse. We are looking at the general conic section because this relationship is general. So for now, we don't want to identify which is which. So we're just looking at them as a general case. So let's take a simple problem now. So we want to consider this problem so I can help us understand the general relationship for conic section. Now the question says, obtain the equation of the conic. So obtain the general equation. So no specification, whether parabola, hyperbola, or ellipse. So obtain the general equation of a conic that satisfies the condition. And what is the condition? They gave us the directrix. Remember when I earlier gave the diagram, I told you that the directrix is a line, So they have given us the equation of that line. So let me redraw that. So we have something like this. This is our y, this is our x. Now say this is our directrix. The equation of this directrix is given as 2x minus y plus 1 equals 0. So they gave us the equation of the directrix, right? Now, say we have a point. Now, you notice our focus, which is the fixed point, is at the origin. So the focus F is at the origin, which is 0, 0. So this is where we have that fixed point. And they gave us the eccentricity. Now, what is a conic? A conic is a path traced by a point such that there is a constant ratio between the distance from that point to the focus and the distance to the line. Now, if we pick a point, if we pick some random point here, so it would mean that the distance from F to that point P, which has variables x and y, and the distance, perpendicular distance to some point A on that line. The ratio of this distance to this distance is a constant, which is what we mentioned. So what it means is that the ratio of PF to the ratio PA would always be constant. And what is the constant? The eccentricity. So this is the relationship we'll be needing to be able to solve this problem. So it means that first of all, we should be able to get PF. If we get PF, we get PA, we know E, we equate this and solve. So let me rub this side. So I have, let's find PF. PF is a distance from that point. What is the point we are dealing with? We are dealing with a point P with coordinates x and y. So PF is the distance from this point P to the focus. So how do we get the distance between these 2 points, point P and the focus? It's very simple. So it's going to be the square root of x minus 0 all squared plus y minus 0 all what? Squared. So this is how I can get this. But one of the things I want to do, I want to take this square root to this side. So I would have pf all squared. So it means in this case I won't be needing the roots at this point again. So x minus 0 is what? X. Then you have x squared. Y minus 0 is y, then you have y squared. So this is what I have as this. I'm doing this for a reason, right? Yes. Now the next thing, I want to get the distance PA. Remember, PA is actually a perpendicular distance from that point, right? So how do we get perpendicular distance of a point from a line? We did that under straight line. So let me remind you. So the perpendicular distance PA is going to be the absolute value of px plus qy plus c, if you remember, all divided by the square root of p square plus q square. So this is how we can solve for perpendicular distance, where what you have here is the equation of that line, and these are the coefficients, right? So using this, I would have that PA would be given as, what is my equation? My equation is 2x, right? Because my point is x and y. So 2x minus y plus 1, all divided by the coefficient. The coefficient is 2 square plus minus 1 square. So this is what I have. So that this becomes the absolute value of 2x minus y plus 1, all divided by, this is 4 plus 1, which is square root of 5. So this is what I have, right? Yes. So I've gotten PF, I've gotten PA, that distance. Yeah, my eccentricity is half. Now from this relationship, we can actually say, I would cross multiply. We can say that PF would be equal to E times PA. We can say this. And to simplify problem for us, we can still say that PF squared, if I square through this, would be equal to E squared PA squared. So this is also true. Why am I doing that? So that I can eliminate square roots. That is why I'm doing that. So if I do that, I want to get, remember this is PA, right? Yes. So I have PF squared. What is PF squared? I'm going to substitute. That is x squared plus y squared, which is equal to, what is our eccentricity? Our eccentricity is 1 over 2, then all what? Squared. Then what is our PA? PA, not PA squared. So we have PA to be what? 2x minus y plus 1, all divided by the square root of 5. So this all what now? Squared. So if I do this, I would quickly see that 1 over 2 squared is 1 over 4. And this 4, when it multiplies, I would have, this is 4, multiply this, it becomes 4x squared plus 4 here, multiply this, it becomes 4y squared equals, I'm left with, this square would affect this, it becomes 2x minus y plus 1 all squared divided by, when this square affects this, it just becomes divided by 5, right? Yes. Now I'm going to cross multiply. 5 would multiply this. This would give me what? 20x squared plus 20y squared equal to what now? This is going to give 2x minus y plus 1 into 2x minus y plus 1, right? That is what the expansion means. So I wouldn't waste time because of my space. So I'm going to write the result of that expansion. I'm going to write the result of the expansion. So that would give me let me put the results because I've done that. So that would give me, so if you expand this because of space and then write this, you get a final expression as 16x squared plus 4xy plus 19y squared minus 4x plus 2y minus 1 equals 0. So this is the equation we would get. It's very simple to do. When you expand this, just this times this, this times this, this times this. When you do this expansion, this is the final result you will get. So the equation we have gotten is the general equation of the what? The conic, which we don't want to tell whether it is parabola or ellipses or hyperbola, even though we can tell, but for now I don't want to take you through that process. So this is the general equation of that conic, right? Yes, so at this point I'm going to stop the video. In my next class I will take one more example and then I will dive into the terms that are used in conic section. Terms, one of the terms that is used in conic section is focus. So you would always hear us mention focus. So what is focus? We are going to learn it in our next video. So you really need to understand these terms. When you understand these terms, you won't have problem with any question under parabola, ellipse, and hyperbola. You'll be learning focus, you'll be learning vertex, you'll be learning eccentricity, you'll be learning directrix, you'll be learning asymptote, you'll be learning one more point you'll be learning, latus rectum. So we'll be learning all these things. So do well to subscribe if you are yet to subscribe, so that when I post the next video, you'll be updated. Thanks for watching Prime Concepts.